wireless connected to the box, and then the box is connected. This is a headset or lav mic. It's got a cable connected to a box on my belt, which is wirelessly connected over there to connect so you can hear me. But microphones come in all shapes and sizes. The main differentiating thing is for different applications, different uses. The mixer, which I have over here, this is like the hub that everything connects to. You can see I've got cables up here for incoming signals. I've got knobs and buttons for adjusting the sound. And then I've got one big knob down here, which is the master volume of everything. But this is the hub that everything connects to. This manages our audio sources. Mixers can look very different. Maybe this is similar to what you have in your school, but they come in a lot of variations. They all pretty much do some basic things all the same. This is an analog mixer, which is a bit different from a digital mixer, which is a little bit more advanced. They cover some of the same things, but the digital mixer will have a few more features and capabilities. But the basics are the same, and often they're even laid out the same. So we'll go through some of this a little bit more. In addition to microphones and mixers, we also have speakers. I have one over my shoulder just here. This is an active speaker, which means it has an amplifier built into it. So you can see I've got an incoming sound here. I've got a power cord connected here. And then I've got some knobs to make some adjustments on the speaker. An active speaker or a powered speaker like this is different from a passive speaker or an unpowered speaker, which would also require the use of an amplifier. And that would sit between the mixing board. We come out of the mixing board and we would go into the amplifier and then from there into our speaker. In this setup, I'm going straight from my mixing board directly into my speaker. And then we use cables to connect it all together. There are a host of different types of audio cables. I'm going to cover a few of them today. The first, we'll start here. We'll start with this. This is an XLR cable. The connectors look like that. It's got 3 little pins in there. This is an XLR, often called, a microphone cable, because it is the most common cable used to connect microphones. It can also be used to connect DI boxes. We'll cover what that is in just a moment. But this is that same cable here is connected on the back of this box. We also have 1/4" or instrument cables or patch cables. It's called a 1/4" because that is the diameter of the connector. That's a 1/4" cable. 1/4" cables come in a couple of variations. This one is a TS. This one is called a TRS. And the difference between these two, you can see these little black stripes here. The one with 1 black stripe is TS. That's this one. The one with 2 black stripes is TRS. The difference, these cables can carry the same sorts of signals. They can also carry different sorts of signals. The main difference is that the TS is what we call an unbalanced cable, and the TRS is what we call a balanced cable. This microphone cable that I showed you a little earlier here is also an example of a balanced cable. I should tell you what 1/4" cables are used for. These are this cable, this one that we showed earlier, this is most commonly used for instruments like guitars or keyboards. Sometimes they are used to connect other sound equipment, but very often it's used for instruments. So sometimes it'll be called an instrument cable. Another common cable that you may see is a 1/8" or headphone jack. Again, 1/8" is descriptive of the size of the connector. This would be common on your mobile device, or maybe not anymore. maybe on a tablet or a laptop. This is a pretty common connection. It's also the connector that's on any pair of wired headphones with a cable. This is going to be on one end of them. So that's the 1/8 inch connector. And then a lot of media devices, some being a little bit older, have these sorts of connections. These are called RCA. There's 2 of them because they're a pair. They each carry part of a stereo audio signal. So you can see right here on my mixer, there's a red and a white plug. That's for these guys. Red goes to red and black and white match. Sometimes they'll be labeled white also. And then I mentioned DI boxes. Well, this is a DI box. I'm going to unplug it so I can show it on the camera here. This is a DI box. It has 1/4 inch. This type of cable can connect on this end. It has that on one side, and it has an XLR connection on the other side. This is a very handy box for connecting instruments and devices to your sound system. It's a great way to get that 1/4 inch sort of connection into your mixer, which maybe only has those XLR connections. So it converts signals into the sort of signals and connections that this mixer wants to receive. It can do a few other things, and one of them we'll get to a little bit later. One of them is that it often has a pad button, which can make your signal quieter. Padding the signal means to lower it. There's also DI boxes that are Bluetooth enabled, where you can connect a mobile device directly to this box. No cables needed, and then from the box, you can connect that into your sound system. That can solve the problem where you're doing a presentation or a class and you want to play media from a tablet or a phone that doesn't have physical connectors, but it does have Bluetooth. A Bluetooth DI can be very handy in that situation. The other button that is on a DI, I will show you here. It says right here, lift, and there's a little button. Lift can help solve a problem, which we will revisit later, but the problem that we can sometimes get in audio systems is a hum, a buzz, and that can be caused by any number of things, sometimes a bad cable or sometimes electrical interference. And that lift button, or on some DIs it might be called a ground button, or GRND might be the label, can help eliminate those hums. So that's another feature of DI boxes. You may wonder, why are there so many different cables and connectors, and why is it so hard to connect? Why can't I just use little adapters? I've got this cable, and I think I've got an adapter to get this sort of plug into that sort of plug. Why can't I just use an adapter? Why would I need a DI box? You probably can use an adapter, and it might work fine for a little bit. But here at Horizon, we often recommend it's best practice to use the right cable for the right situation. Little adapters can often be faulty, or they can be a point of failure. Sometimes they're not the most robust. And so we recommend using the right cable for the right situation. Adapters are great in a tight spot where you don't have time to source the right cable and you just need it to work. But I've sometimes likened it to, why don't we eat cereal off a plate? You can do that. It might work, but it might get messy. In a pinch, sure, you can do it if you really need to. That's kind of like using an adapter. It's better to use a bowl. It's better to use the right cable for the right situation. Yeah. So how does this all connect? We got all these cables. We have all these devices. Let's talk through a few connections that you maybe have seen or you might need to make. So if we revisit our audio mixer, which is the hub, the central piece, we want to get sources like instruments or microphones or a laptop that's playing music. We want to get all those things into the mixer so that we can adjust the volume and we can mix. And we use all these different cables to do it. So first, the microphone. This is a pretty easy connection to make. I've got my mic, I've got my microphone cable, and it is coming directly into my mixer. We covered that a little bit earlier, but no harm to review. So that's just one cable connected into my mic, connected into my mixer, and then I'm good to go. The wireless mic, as I mentioned, is connected wirelessly with these antennas to this box, and then the box, the receiver, is connected with that same sort of microphone cable. This exact one that we saw earlier is connected right here. And I've actually got them connected into my mixer. This wired microphone is connected into the first channel. There's a 1 on my mixer right here. The wireless microphone is connected into the 2 on my mixer. And that connecting a wireless microphone is the same for a wireless mic that you would hold and talk like this, and a wireless mic like this. They both connect to a receiver. Ooh, I want to get this in the holder. There we go. They both connect to a receiver and then connect with an XLR cable. What about a keyboard or a guitar with a pickup in it, or any instrument that a student might bring in with a pickup? That's a situation where 9 times out of 10, it's going to have this sort of plug coming out of it. For a guitar with a pickup, this is going to be the connection. It plugs into the guitar, and if they're not using an amplifier or anything like that, then you can plug straight into a DI box like this one, and then come out of the DI box with that microphone cable and connect to your mixer. In this setup, this DI box is connected into channel 3. And then I mentioned the Bluetooth DI. I don't have one here on my setup, but it is basically like this, and it has a pair button. Pair, and then on my device, I choose that DI, and then I've made a connection. We've often been asked what the best way to connect a laptop to a system for a presentation that's both video and audio. Many times your school might just have an HDMI plug that's plugged into the laptop to get the video signal coming through. What about the audio signal? This DI here, I'll show you on the camera here, is a great option designed sort of for that use. It has a headphone jack cable, an 1/8-inch connection, built right into it. So it comes with the cable and it's physically attached. So you could plug this into your laptop and then connect it to your sound system with an XLR. And we've been asked that question so many times, and so I include that as a little bonus. That's called a stage bug made by a Canadian company called Radial. Okay, so once we've got everything connected to our mixer, now what? We've connected a microphone, we've connected an instrument with a DI. Now what? Well, I'm going to talk through some of the connection points and the knobs and buttons on a mixer. At first glance, it can be a little bit intimidating because there's a lot going on here. So let me try and break it down. A mixer, we're going to look at this strip right here that has the number 1. It's arranged vertically with the incoming connection here at the top. So that's the incoming signal from a microphone. It also has a 1/4-inch connection. And then it's got a knob up here. On this mixer, it's not labeled, but this knob is generally labeled gain. On this model, it's called line or mic. That's the name up there. But what it's doing is adjusting the level of the incoming signal. So when I turn that knob, and if I tap the microphone that's connected, you can see I've got a little indicator light that's illuminating. And I've got a couple buttons here. One has a picture of a guitar. Often that button will be called mic or line, and that's to switch between an input for a microphone like this, or an input for a direct instrument connection that would be like this, a 1/4-inch connection. Now, I have 2 options to connect something for channel 1. best practice would probably be connecting just one connection into one channel. I can physically connect two things, but that's going to lead to some problems. So use one connection per channel. That's a best practice. And then as we go, okay, so I've got an indicator light here with this knob adjusting my incoming signal gain. And we'll talk in just a moment about, actually, let's talk about it now. Why not? To adjust the gain on that incoming signal, what I want to do is have down here on the bottom, you can see right here down by my finger. Can we see? There we go. There's a little red light right here with a button beside it that says mute. That mutes the sound coming in on this channel so that nothing's going to make noise. My speakers aren't going to go boom. Nothing's going to pop. Nothing's going to be super loud. So I am going to, with that button turned on and my volume knob that is down here on the bottom right here, this is a volume knob. Some mixers have a slider or a fader. This is the same. One is just a rotary knob. One is a fader. So I've got that set with the lowest setting, and I have the mute button pushed. To properly set the gain, you're going to talk into the mic or play the instrument or play music from the laptop and adjust that input gain, this knob that's at the top, until we see the indicator light. Most mixers are going to have something here. We probably don't want it to flash yellow or red. I'm not sure if this one's capable of flashing yellow or red. Some are. Yellow or red are kind of like stoplights. They're giving you that warning. Oh, something's exceeding the limit. So we want to see green. And right now I'm seeing green when I tap that microphone. Great. Now we've done it. We've set the incoming gain. So next are these three knobs right here. 3 is very common for this section. It's called the EQ, and you can see right over here it says EQ. That stands for equalization. Some mixers, sound mixers, will give you more options for equalization, but essentially they're doing the same thing. And EQ adjusts the sound of the sound. This is arranged into high, middle, and low. And these would be similar adjustments to like your car stereo or your home stereo system. You want more bass, you can turn up the low end. And this mixer gives me an adjustment for high, middle, and low. They're labeled with numbers: 10 kHz, 2.5 kHz, 100 hertz. Those are measured in hertz. That's frequency. That's a measure of the spectrum of sound that you're adjusting. Not super crucial to know. If you know high, middle, and low, that's probably going to serve you well. So that's the equalizer. That shapes the sound of the sound. These next two knobs, this blue one and this white one, the blue one's called aux. That is a way of sending audio from this channel somewhere else on the mixer. Say for a monitor for a performer who wants to hear themselves so they can perform. You would most commonly use an aux for that. This mixer has an effects section where you can apply some sound effect like reverb or delay or chorus. And this knob adjusts how much of this audio channel is being sent to that effect. The next knob down is called pan. You can see that right there, pan. This adjusts the placement in the stereo field. In a sound system that's configured with two main outputs, stereo, left and right, the pan knob will adjust the balance of the sound in each of those speakers. Is there more to the left side? Is there more to the right side? Most of the time, we're going to have that set in the middle. And then as we covered below, there is a mute button with an indicator light. If I just sneak this camera forward, maybe we can see that. There's the mute button with the indicator light right here. And then at the very bottom, we have that large knob, which is going to control the volume for this channel. Okay, I'm going to move this camera back. Sorry for the adjustment, folks. There we go. Now we can sort of see everything again. So I'm going to now turn up this channel. Oh, there we go. The speaker behind me is on. Maybe you can hear that coming through. And we can see some lights coming here. So this input channel That was number 1. All of these knobs and buttons apply to this incoming signal. And now we have some more incoming signals, and those strips apply to those incoming signals. Once it reaches the bottom and I'm adjusting this knob, then all of these are mixed together, and this knob over here that's called main or master, it adjusts the level of all of the signals. So each one of these knobs adjusts an individual level. This main one adjusts the level of all of them. And that covers most of the general features that you're going to have on just about all audio mixers. Some might be bigger, some might be a little bit smaller, but for the most part, that's how they're going to be laid out. In audio, there can be a lot of common problems that we face. There's a buzz that I don't know how to get rid of. Everything is connected, but I'm not getting any sound. And so I wanted to cover just a couple of troubleshooting, what to do if it's not working the way you expect it to. And the first most common problem is maybe no sound. This is a common problem, and these would be the steps that we'd recommend you take if you're not getting sound. First, is everything powered on? Sometimes we might assume something's powered on, but assuming sometimes can get us into problems. So we check. Most mixers are going to have a power on button somewhere. So we'll find that. Okay, I've got mine. It's back here. I see lights on the mixer. So that generally is a good sign telling me that it's on. But you're going to check that. You're going to also check your power amplifiers, that they are powered on. And in this case, a powered speaker, you're going to want to check that it's powered on. If you're sure that everything is on, the next thing to check is that all the cables are seated properly. If I'm wanting to get sound out of this microphone and the cable is just like that, it looks like it's connected. But if I look closely, it's not fully connected. So you're going to want to check to ensure that all of the cables are connected securely, both on your sources, like a microphone, and on your console. So make sure all of those cables are seated properly. And then the next thing to check would be those mutes on each channel. Do I have the microphone that I'm trying to get sound on? Is it muted? Check that mute button. And then after the mutes, you're going to want to ensure that you're adjusting the correct channel. If I'm hoping to get sound on that microphone, but I'm adjusting a channel that it's not connected to, I'm not going to get sound. So you're going to want to ensure that you are making the adjustments on the correct channel that you're connected to. And then lastly, once you've done all that, if you're still not getting sound, then you can check that gain knob at the top and the volume or level knob here for each channel. And generally following those steps, you're going to cover a lot of ground, and chances are you're going to solve your issue. Another common problem is feedback. What is feedback, and how do we stop it, or how do we prevent it from happening? Feedback is that sound that occurs that's like a high-pitched screeching, or like a woo that gets louder and louder and louder. Feedback is caused when a microphone is turned on in a speaker and the microphone is picking up its own sound from that speaker. It creates a loop, a feedback loop, and what's happening is the microphone is picking up a sound from the speaker. It's going back into the microphone and going through the amplification system again and getting louder. And then the microphone is picking up the louder sound again. It's going back through the amplification system and getting louder again. And it all happens very quickly, and it can get out of hand very fast. It's not pleasant to hear, and it can actually, there's a small chance that it could damage your system if it goes on for too long. How do we solve it? How do we prevent it from happening? The first thing to check is that a microphone is not pointed towards a speaker. If that speaker was on and this microphone was on and I pointed it like that, I might be into some problems, especially if I had this microphone up loud. So the first thing to check is, how far is the microphone from the speaker? Is it pointed towards the speaker? Can we change that? If a student or a performer is performing or singing and they're holding a microphone and maybe they're really far away from the microphone and they're too close to the speaker, that's a good chance for feedback. What you can do in that case is encourage the performer to bring the microphone closer to their mouth. Or if it's in a group setting, you can move the group of students closer to the microphone to be picked up, or move the microphone closer to the group of students. Another way to address or reduce the chance of feedback is to make adjustments on your audio mixer by lowering the level. Is it louder than it needs to be? Well, let's adjust it down. And that gain knob, the input gain, this knob here at the top, that's probably going to be a great place to start by lowering the gain a little bit. You don't have to drop it all the way, but maybe it was here. We're getting some feedback. Okay, I'm going to lower it a little bit. That will, in effect, sort of almost lower the sensitivity of a microphone. Doesn't really change the microphone, but that's sort of the effect that it has. And then if all of this keeps persisting and you're still getting feedback on a performer's mic, you could also encourage the performer to project more. Maybe they're very soft-spoken, and what they need to do is speak out a little bit more. So those are some common things that you can do to address feedback. Buzzing or humming is another really common issue. This is caused by a ground loop. You don't really need to know what that is, but that's generally what causes it. And this is where a DI can come in handy. Let's say I've connected a guitar with one of these cables directly into my mixer, a 1/4-inch cable directly connected like that. And I've got the other end connected to an acoustic guitar or a bass guitar or an instrument that a student's brought in. And when I turn up the sound, I get a that's a common sound that can occur with a lot of instruments. And a DI connected the way we showed earlier, then with a microphone cable, with that ground lift engaged, it's designed to fix that problem. So a DI can be your best friend there. Some instruments in guitars are naturally noisy. It's part of the sound. DIs can sometimes help with that. Sometimes they can't. But it's the first place that I would start to address a buzz or a hum. Another way to address a buzz or a hum is if you have something connected to your sound system, like this. This is a cable and a DI connected to the sound system. If I turned that up without anything plugged in, it might hum or buzz. But there's nothing plugged in, so I don't need to have that turned up. I could find that. Okay, what channel is this connected into? It's connected on number 3. I'm going to turn down number 3. The hum and the buzz might go away. So just ensure that you don't have any unconnected cables being turned up and amplified in your system. That's another thing to address. The next problem would be volume problems. What if it's too loud, or what if it's too quiet? How do we get kids on stage who are singing? How do we get them louder? How do we get more sound? That can be a pretty common thing for a choir or a group performance. And the first thing I would do is reposition the microphone. Are they near a microphone or microphones? Let's move those microphones a little bit closer to the kids. Chances are that's going to increase the pickup that the microphone is doing, and hence get you a little bit more sound. So reposition the microphone. That would be step 1. Step 2 would be reposition the performers. Can the kids move closer? If neither of those are possible, then the next step would be to encourage them to perform louder, to sing louder. We kind of covered that. If none of those helps the problem, then I'd suggest considering a different type of microphone. The microphones I have here are both what's called a dynamic microphone. It's a simple microphone that doesn't require power. There are some microphones, like a pencil condenser, that's a different type, that are designed to be a little bit more sensitive, and they have stronger pickup. So swapping out the microphone to a different kind can also solve that problem. What if a main speaker, like a speaker, is quiet, but all the levels are really high on my mixing board? I've got all the knobs or the faders all the way up, but the sound isn't loud enough coming out of the speaker. The steps I would take then are, first, if you have amplifiers, so passive speakers with an amplifier, mixer, amplifier, then speaker. Most amplifiers have the ability to be adjusted. They have a knob on them where you can turn the amplifier up, hence getting more output from a speaker. So that could be the first thing to investigate. If you have an active speaker like these ones here, I'll go back to this one. This speaker has its own volume and output right here. I can turn that up to get more. Turning that up will increase the volume coming out of this speaker. So if you have active or powered speakers, adjust at the speaker. And 3, if you've tried both of those steps, then that might be a situation where you need to potentially investigate a different or more powerful speaker. There's a chance it could just be the speaker not being capable of producing more sound. So another common issue that is sort of a volume problem is, what if you get crackly or distorted sounds sometimes? That might be an indication of something called clipping, which means more signal is coming into your mixer or going to your speaker than the mixer or the speaker is capable of handling. And it's distorting as a result. Sometimes if you have a mixer that has LED indicators on it, this will be you're hitting those red lights. Those red lights are showing. So that's the first indication. If you're getting those red lights, let's say this microphone was on a percussion instrument that's nice and loud, and I had it up really loud and I was getting red lights. The first thing I could do is lower that gain lower. That's the incoming signal level. I can lower that. That might solve the problem. Number 2, or the second instance, is if you're sending more signal than your speaker can handle, you might hear a distortion in your speaker. You simply need to turn things down or back things off. It could be your amplifiers or it could be your speakers. They do have thresholds where you can exceed it and they won't be able to keep up. In that case, you just need to turn it down. And if that's not loud enough for the concert or the assembly, then that would be the time to investigate getting a louder amplifier or a louder speaker. So there we go. We've covered some of the basics of how a system is connected together, some of the components and how they work, how they interact, some of the details of a soundboard, and what to do when things don't behave the way you expect them to, some troubleshooting. And so again, thanks for joining us today. You can find out more about Resource Stage by visiting our website at resourcestage.ca. This video will be there live. Not live. It will live there after we're done today. So if you know someone who this might be beneficial for, you could refer them to that website. It's also on our YouTube channel. Search Resource Stage in YouTube. We have more upcoming seminars like this one and covering other topics. We'll be redoing this seminar in January, covering both lighting and sound. So again, if you know someone for whom this might be beneficial, we'd love the reference. Resource Stage is the home of our free training and free resource seminars. They happen monthly, and they live on our YouTube page, so you can view any of our past training seminars there. We are Horizon Solutions. We do rentals and sales and install and design in the audio, video, and lighting world. If you have any questions or problems or issues, give us a call. We'd love to help you out. If you're looking for lights for an upcoming show and you want to rent something, give us a call. We do that. You can check out our website at horizonsolutions.net. Again, I'm Jordan. Thanks for joining us today. Have a great rest of your day.